Shaper, I just wanted to quickly go through the gas laws lab with you to help you with the discussion quiz. So in this situation, we did not use the lab in the course. You are welcome to use it. I just felt that there was a couple areas that it did not clearly show the relationship significantly enough to catch it because it's a small screen. So instead what we did was we used a PhET simulation on gas properties, which I hope you'll go in and use because it's very helpful in understanding the gas laws. Because one of the things that you can do is you can adjust the parameters. When we first did this in class, we had no parameters, but you can go in and make something constant or the same, so it stays the same, and see what happens. That will really help you with your questions. Noticing what happens when you add pressure. What happens when you add temperature? What happens when you change the volume? So the questions on the discussion quiz can be related back to this lab. You can also use this little clip here on the ideal gas laws, and you'll see that I have where volume is constant, pressure is constant, and temperature is constant. There are some more details that are not included in this portion for chemistry, but you would include them in a more advanced class. So this is just a simplified idea of these three laws. So if you have a sample of gas molecules that are at the same internal pressure, that's the key, same internal pressure, what would the sample look like with the lowest temperature? So you're going to go to Boyles Law here. Pressure is constant. So if the temperature is low, what does that tell us about the volume? Think about the energy. When things are closer together, they usually have less energy, and energy is related to temperature. So which of these examples would be the best for lowest temperature? Because we know that temperature increases, volume increases. And then we can also say temperature decreases, then volume decreases. In this case, we're using temperature decreases. So the lowest temperature means the what about volume? In the next question, it's talking about pumping gas into a container, but keeping the temperature the same, and then looking at what will happen to the pressure. So in this case, because we have temperature the same, it means we're using Boyle's Law. Temperature is constant. So when we add more molecules, but the container is staying the same size, what will happen to that pressure? Think about as you pump those molecules in. At each pumping of new molecules, what's going to happen to that pressure? Is it going to stay constant? Is it going to increase, decrease, or fluctuate? Remember, with Boyle's Law, it's saying over here in the corner, it's pretty small, but it will say that if temperature is constant, volume increases, pressure does what? It's inverse of opposite. The next question asks about the average kinetic energy, and we learned about energy previous to this, but it's telling us that energy is proportional, or the average kinetic energy is proportional to the temperature in degrees Kelvin. So Kelvin is the way we measure temperature in a laboratory. So proportional meaning one increases, the other increases, one decreases, the other decreases. So if the temperature increases, what will happen to the kinetic energy? Will it cause the particles to move slower, faster, or keep the same. So if the energy and the temperature is related and you increase the temperature, what will happen to that energy? That is the question you're answering for this case. Choosing between slower, faster, and the same. Higher temperature means what about the movement? Right, so in this situation, the temperature is constant. So if the temperature is constant, which sample will have the highest pressure? So in other words, it's comparing the volume to the pressure. And again, temperature is constant. That's Boyle's Law. And those are opposites. So that means that if we want something with a high pressure, what do we need? Do we need a high volume, the same volume, or a small volume? The last question is an essay question. It's an application question where we are proposing an experiment. Here is the information we have about our experiment. Our end goal, my slides changed. End goal is that we have 3 different size balloons filled with carbon dioxide using the reaction of baking soda and vinegar. So how can we get 3 different sizes of balloons? Let's go down and read our conditions to see how this experiment is going to be set up. And then we have to look for what is constant, what is going to stay the same, and what we can change. So in the experiment, we're going to place baking soda in a balloon using a funnel, and we're going to place it aside. Then we're going to place vinegar in each of the containers. Next, we're going to carefully place the opening of the balloon over the bottle opening. That means we don't want to spill the baking soda, so maybe someone's going to hold it or we're going to twist the area so no baking soda accidentally falls into the bottle. When we're ready, we're going to dump the baking soda in the balloon into the bottle. So it's going to be dumped from the balloon into the bottle. And then that reaction is going to cause a gas of carbon dioxide. And we're going to collect the gas, which is going to blow up the balloon. Each balloon needs to be a different size. So what we have constant is the amount of vinegar. So if you read the question, it says, propose your method for creating and trapping 3 different size carbon dioxide balloons if you're given the following supplies. 3 flasks each with 100 milliliters of vinegar. So 3 flasks, 3 containers, all of them have the pre-measured amount of 100 milliliters of vinegar. 3 balloons, that's another constant, they're the same type of balloon, and 30 grams of baking soda. So think, what is it that you can change or adjust, that's your independent variable, to collect your dependent variable, which are the 3 different sizes. So think about what you can adjust in order to create 3 different size balloons. All right, so good luck. If you have any questions or concerns, please let me know so that I can help you. And we will see you next time.